Hi guys! Welcome to enginerdmath channel. In this video, we will test and review a particular digital multimeter product. So if you want to learn more about this, just keep on watching. Okay, so I have here a digital multimeter which was sent to me by Kaiweets. So Kaiweets reached out to me and asked if I can review their new product, which is this digital multimeter, to test for its quality and accuracy when measuring different electrical parameters. So disclaimer that this video is not a tutorial video, but it's just a direct review of the product to test whether if this multimeter is a good buy for you. So by the way, I already have a video on how to use digital multimeter. So if you haven't watched yet about that, I will just link a card on the upper right so you can watch it first as well. Okay, so I will also link the description box below every information to this product so that you can check it yourself. Okay, so let's start to unbox the product and let's see what's inside. So by the way, it has a good box and you will see that it is RoHS compliant as well as European laws compliant, and it's designed and conforms to IEC 6100101-1 Cat 3 600 volts. Okay, so let's open the box. So inside the box we have this pouch or container for the multimeter, and then we have this user's manual. So in this user's manual you can see the different parts of the multimeter and as well as the different rules and steps on how to properly use the multimeter, as well as the different specs for the accuracy of the multimeter. So we have the DC voltage, the AC voltage. So we have also the DC current, AC current, resistance, the capacitance, the frequency/duty, the diode, and continuity. Okay? So by the way, the pouch or bag for the digital multimeter is good and handy. So whenever you want to bring it, you can just hold it by your hand, keep it inside your bag. So it's good that the package includes this pouch as the container for the digital multimeter whenever you want to bring it. So inside we have the digital multimeter itself. So it is Kaiweets HT112B, and we also have the test probe. So we have the red and black probe. So red for the positive and black for the negative. So it also states here that it has a 10 amps maximum rating and it is 600 volt Cat 3. Okay, so the tip also has a cover, which is this one. So whenever you want to put it, you can do so, or if you want to remove it, you can do so when testing. Okay, so it has cover for both black and red probe. Okay, and then we have the battery. So the battery for the multimeter is CR2032 3 volt lithium battery. So we have two batteries for the digital multimeter. So let's go with the digital multimeter now. So this is the digital multimeter. So it is a small digital multimeter and it includes a cover, so you can remove this cover. So this is good for protection for the digital multimeter to avoid scratch, and whenever it falls, this cover somehow protects the digital multimeter from breaking. So let's try to put the battery first. So there is a screw, so we need to remove it first before we can put the battery inside. So let's try to unscrew it first. So inside, we will see two circles where we will put the two CR2032 batteries. Okay, so I'll just get the two batteries. So it is negative here. So in the battery, you will see that's positive here and obviously negative here. So we will put it this way. Okay, so it beeps. So therefore, it is now open. So I'll just return the cover at the back. I will put the screw again. Okay, and then I'll return the cover so that we can proceed to the monitor of the digital multimeter. Okay, so here you go. So we have the front side of the digital multimeter. So as you can see, we have the different button here. We have the switch button. We have the smart or func button. We have the H/light icon button, and we have the cell or also I think light icon as well. And you can see the different labels for the positions of the probe. So we have the position for the probe for current, and we have the position for the probe for different parameters like the capacitance, voltage, resistance, diode, continuity, and live. And in the middle, we have the COM, where we will put the negative probe or the black probe. So under this connection, so we have 600 volt Cat3, and then under these connections, we have the 600 milliamps / 250 volt max rating. So it also states that it is 6,000 counts, and underneath, this is where we will put the probe. So now, what amazes me is the monitor itself. So it is not your typical digital multimeter where the selector for different parameters is included in a selector knob where you can rotate or adjust the switch in order for you to get the particular parameter that you want to test. So here, it is included on the screen. So you will see that it has different parameters that you can measure. We have the voltage both for DC and AC. We have the resistance, the continuity, the voltage again for DC and AC but in a millivolts range. We have the frequency and duty cycle. We have the capacitance, the diode test. We have the AC and DC current in the microamp range. Also, AC and DC current in the milliamp range, and we have the NCV or live measurement. So NCV I think stands for non-contact voltage. So this multimeter can detect whenever there is a voltage whenever you place it near a voltage source. So it has a NCV sensor at the back as well as I think the flashlight. By the way, it also has a temperature sensor, which right now it measures around 30.3 degrees Celsius. So just to check for each button, let's try to turn it off by pressing this power button. So let's try to hold this switch button and the multimeter turns off. Let's try to open it again by pressing it. Okay, so it opens. So by the way, this multimeter is auto range, so it adjusts automatically to whatever range of values of parameters you are measuring. Okay, so initially we are under the auto range. So the auto range means that it can measure automatically these three parameters: the AC and DC voltage, the resistance, and the continuity test. So these three parameters are the default measurement for this multimeter. So it automatically measures whatever among the three you are testing. Okay, so let's proceed with this button, the cell or flashlight button. So whenever you press this button and hold it for a while, you will see that the flashlight will light. So it is one of the purposes of this button, to light the flashlight at the back when you press it for a while. And then to turn it off, press it for a while again, and you will see the flashlight turns off. Now another function of this is to select a particular parameter within a particular smart function. So let's have this smart function button now. So if I try to press it, we will change the position of the selector knob here on the DC and current voltage in the millivolt range. So if you want to change it, so right now we see that it is under the DC. So if you want to change it to AC, you can just press this cell button and it will now turn to AC through RMS. So you can just go to the other parameters to be measured in this digital multimeter by just pressing this smart function. Okay? Now we have also this H/light button. So this H stands for hold. So whenever you are measuring a particular parameter and you want to hold that value, stay it on the screen. So just press H and you will see that H will appear on the screen, meaning it will hold the value on the screen. So it will not be removed unless you press it again. Okay? And then for the other icon, it's just the light for the monitor. So if you press it and hold it for a while, the monitor will have light on it. And then to turn off the light, you just hold it again. Okay? So that's how you use the different buttons and functions of the digital multimeter. So let's now proceed to the actual test of measuring different electrical parameters to check for the accuracy of this multimeter. So I already inserted the red and black probe on the digital multimeter, so we can proceed with the testing. Okay? So let's start with the measurement of AC voltage source in our home outlets through this extension cord plugged in directly to the wall outlet. So we expect to measure around 230 volts through RMS, right? So if we try to measure the AC voltage across this socket, so we can measure around 236.5 volts AC through RMS, and the frequency is 60.1 Hz, which is what we expect, right? Next, let's try to measure DC voltages. So let's start by measuring the output voltage of this 19.5 volts AC to DC adapter. So let's plug it in. And now, it turns on. Okay? So let's try to put the positive inside and the negative outside. Okay, so therefore, we can measure 19.5 volts. Okay? Next, let's try to measure the output of this AC to DC adapter, which is rated at 12 volts DC. Okay? Again, for the positive, we put the probe inside. And for the negative, we put the probe outside. Okay, so the measured voltage is 12.3 volts, which is close to 12 volts, right? Now, let's try to measure the output voltage of this power supply. So we can have here 5 volts and 3.3 volts. So as you can see here, we can have 3.3 volts and 5 volts. So now the switch is located at 3.3 volts. So let's try to measure it. Okay, so we just put the positive here and the negative here, and we measure around 3.32 something volts. Okay? Next, let's place the switch on the 5 volt position. So we can expect now 5 volts measurement. So again, let's put the positive here and the negative here. So we see the measurement is 5.025 volts. Okay? Next, let's measure the resistance and continuity test. So let's start with continuity test by placing the two probes together, touching each other. So it beeps, therefore the multimeter detects continuity or short connection, and we see that the resistance is 0 ohms. Also, there is a green light indicator that there is a short connection. Okay, let's try to test also the continuity test for the breadboard. So this is connected, right? So if we try to put the probe here, we must detect a short connection. So therefore, it is shorted. Okay? Next, let's measure resistance. So I have here 6 resistors with measurements of 10 ohms, 100 ohms, 1000 ohms, 10,000 ohms, 100,000 ohms, and 1 mega ohm. So let's try to test the accuracy for the resistance. So let's start with the 10 ohms. Okay, so it's 10 ohms. Next, we have the 100 ohms. Okay, 99.5. Then the 1000 or 1 kilo ohms. Okay, we have 0.997 kilo ohm. Then we have the 10 kilo ohm. So we have 9.95 kilo ohm. Then we have the 100 kilo ohm. Okay, we measure 100.8 kilo ohm. And for the 1 mega ohm. It's 1.002 mega ohm. Okay? Now, let's try to measure the diode test. So, let's press the smart function to move the selector knob to the diode position. Okay? And now, let's test for this diode. This is a 1N4007 diode. So, let's test this diode. So, we have the cathode here and the anode here. So let's put black probe on the cathode and the red probe on the anode. So we see that the voltage drop is 0.589 volts. If we try to reverse the position of the probe, it measures nothing, since the diode is reverse biased. Okay? Next, let's try to test these LEDs. So I have here 4 LEDs with different colors: blue, red, green, and yellow. For each LED, we have here the long terminal as the anode and the short terminal as the cathode. So the anode is on the right and the cathode is on the left. Okay, so let's try to measure the voltage drop across these diodes. Let's start with the blue one. Okay, so it lights and it measures around 2.586 volts. Then for the red, we have, okay, it lights and it measures around 2.087 volts. For the green one, we have, it lights and it measures around 2.305 volts. And for the yellow, we have 1.870 volts. Okay? Next, let's try to measure the capacitance. So I have here 4 capacitors. So the first one has a measurement of 0.47 microfarad. The second is 10 microfarad. The third is 100 microfarad. And the last is 470 microfarad. So let's put the selector knob to the capacitance test. Okay. So let's start with the 0.47 microfarad capacitor. Okay. So we have 474.8 nanofarad. Then for the 10 microfarad, so it's around 10.9 microfarad. Then for the 100 microfarad, Okay, it's around 115 microfarad. Then for the 470 microfarad, it's around 498 microfarad. Next, let's try to measure current. So to measure current, I will use this 5 volt DC source and then several resistors. So I connect 100 ohm resistor, 1000 ohm resistor, and 10,000 ohm resistor, one at a time across this 5 volt voltage source to simulate the current. So to solve for the current, when we have 100 ohm resistor, using Ohm's law, voltage divided by resistance. So we have 5 divided by 100. So we expect 0.05 amps or 50 milliamp. Then for the 1000 ohm resistor, we expect 5 milliamp current. And then for the 10 kilo ohm resistor, we expect 5 times 10 raised to negative 4 or 500 microamp current. Let's start by measuring the current through this 100 ohm resistor. So we put the red probe this time on the other side of the meter because it indicates measurement of current. And then for the selector knob, we just put it in the milliamp range. Since we expect to measure 50 milliamps, right? So in measuring current, we put the meter in series with the circuit. So I'll cut the connection of the resistor to the voltage source. So I put the positive probe here and then I insert the negative probe on the terminal of the resistor. So therefore, we can measure approximately 50 milliamp, which is what we expect. And then next, for the 1 kilo ohm resistor, we expect 5 milliamps, right? Okay, 5 milliamps. And then for the 10 kilo ohm resistor, we expect 500 microamps. So let's place the selector knob in the microamp range so that it is more accurate. So measuring, we have 499 microamp. Next, let's try to measure the NCV measurement of this multimeter. So we just put the selector knob on the NCV position. So if we try to place the sensor here near a voltage source, it must detect it. So I have here the AC voltage source. So when I place the digital multimeter away from the voltage source, it does not detect. But when I place it near it, okay, it detects high voltage source with the H indicator. Okay, so overall, this multimeter is a good multimeter for testing purposes. It's lightweight, it's compact, and the design is good. And it measures accurately different parameters. With its cheap price, this multimeter will go a long way. Okay? So that's it for this test and review of this Kaiweets digital multimeter. So I hope you enjoyed this video and thank you for watching.